Hello everyone, welcome to my final project for the class CIS9367. Today I'm going to present to you that how to use the solver add-in in Excel to calculate the minimum variance portfolio and how to construct efficient frontier. So minimum variance portfolio and efficient frontier are two important concepts in the portfolio theory. So here we assume in our portfolio there are only 3 securities that are Apple, Google, and Amazon. And we would like to construct a portfolio that consists 3 of them, and we want to get the minimum variance, which is also minimum risk for this portfolio, by playing around with the weight for each security. So before we start, we need to set the scenarios and we need to get some data from the website. Here I used Yahoo Finance. So if you search the ticker for the security, for example, if you search Apple, you will get this page. You're probably going to go to the summary page, but to be able to download the historical data, you need to go to this tab. For this specific project, I used the 5-year weekly data. And you can apply your filters and then click on this download data button. You will get a CSV file from Yahoo Finance. And the CSV file will look very similar to this one, pretty much from column A to column G. But since we need to calculate the expected return and the standard deviation for the security, so I added a few more columns and did some calculation to first, because we to calculate the monthly return, and we for the standard deviation I used the built-in formula stdev.p with the arguments of the array of returns to calculate standard deviation for security. And you repeat the same process to get the information for Google and Amazon. So after that, you can go back to the summary page, and in this inputs table, you can reference your data to separate tabs. In addition to the expected return and standard deviation for each security, we also need the covariance matrix for them. So as we know, covariance matrix is symmetric, so the diagonal is the same as this, the variance, which is the square of standard deviation for each security. For the covariance, for example, for Google and Apple, we can use the built-in formula covariance.p with arguments for the Apple return and the Google return to calculate the covariance. So as I marked down here, all the orange cells are the inputs we need to set up the scenario. So now we can go ahead and calculate the minimum variance portfolio. So it actually also explains what we need to do here. So we need to minimize the variance for this portfolio. Here, for the portfolio return, we can use the sum product formula, because basically the portfolio's return is the sum of the return times the weight for each security, and the sum product formula actually can do this for us. For portfolio volatility, you can do different multiplication and addition based on the formula we have, or you can do this matrix calculation. So this is actually a array formula. So here, now we can use solver to solve this problem. So open the solver adding. Here our objective is the portfolio volatility, and we would like to minimize it by changing the weights for each security. And also, as I marked down here, all the green ones are the variables, so those should be filled out in this by changing variable cells. And for constraints, we only have one constraint. Because the portfolio only consists 3 securities, the weight for them should add up to 0. So the only constraint is that the total weight here should equal to 0. And then click on solve, you will get the result here. Because I already calculated, I'm not gonna click on it again because it'll spend a long time to calculate the result. And you can do the same thing to calculate the maximum return portfolio here. So now we have finished the minimum variance portfolio. Now we move on to construct the efficient frontier. So by definition, the efficient frontier is the set of optimal portfolios that offers the highest expected return for the predefined level of risk, or the lowest risk for a given level of expected return. So here we decide to use a defined level of return. So now we set up the return for each scenario, and what we want to do is for each scenario we want to make the portfolio return equals to the return level we set up, and by changing the weight for each security. So for example, for scenario 1, we would like to make this portfolio return equal to the return level we set up for scenario 1, which is 0.23, by changing the weights here. And the constraint is only 1, which is total weight should add up to 1. And then you click on solve, you can get the results for the scenario 1. And you repeat the same process, you can calculate the weights for scenario 2 all the way to 11. So for each scenario, you have the portfolio return and the portfolio risk here. So the efficient frontier actually use the return as the vertical axis and the risk or volatility as the horizontal axis. So here, if you select these area, you go to the Insert tab. In the recommended charts section, it'll recommend you to use the scatter chart, which is very similar to what we have here, just the order of the horizontal and vertical axes are different. So we can first generate the scatter chart, and then we can reverse the horizontal axis and the vertical axis. So here we actually notice that this point is not very good because the frontier is supposed to be very smooth, and also we know for each if we draw a line here, we know for each level of risk we have 2 different level of returns. So definitely we want to take the higher return. So actually, the true efficient frontier is only the half part at the top, because no one, for the same level of risk, no one wants to get the lower return. So for a rational investor, they will always take the top half. But just to illustrate how we construct the efficient frontier, I actually calculate a lot of points here, but I just want to point out the true efficient frontier is only the half one. And thank you for listening.